Hello, grade 12s. I want us to go through the assignment number 1 of 2025. So please, guys, make sure that you treat the assignment with understanding. I'm going to guide you on how we solve some problems here. Remember, the main aim of bringing you this assignment is for the learning purpose. So we want you to learn. So please go through it with understanding. I will be helping with you. I will be helping you. We are going through question 1. Let's read the information together. In the figure, M is the center of the concentric circles. So we need to understand here, what are the concentric circles? What do we talk about when we talk about the concentric circles? So the concentric circles, we are referring to the circles that have the same center. Let me show you an example here. Let me say I have the circle, this circle, and the center, let's say this point represent the center. And let me have another circle again, which has the same center. So let me draw another circle with a red ink. Yes. So these two circles, they are concentric. Why? Because they are having the same circle. They are sharing the same center point. So if I ask you, what is the center of the circle drawn with a black ink? The center of the circle drawn with the black ink is this one. What is the center of a circle drawn with a red ink? Is the same center. So we say the circles are concentric. Concentric circles, they've got the common center point. They are sharing the same center point. So when we look at your assignment here, we see that we have got a small circle. The question is, what is the center of the small circle? The center of a small circle, it's M. The center of this small circle, it's M. Okay, so what is the center of a bigger circle? It's still M. So we say the two circles are concentric. The larger circle has got the equation. So they gave us the equation of a circle. What is the equation of a larger circle? It's x squared plus y squared equals to 4y minus 2x plus 44. Okay, so you are given the equation of a larger circle. Remember, when we are given the equation of a circle can be actually written in two ways. We have got alternative method of writing the equation of a circle. There is this method. Let me erase and I show you the method. There is this method of writing the equation of a circle. The equation of a circle can be in this form: x minus a squared plus y minus b squared equals to r squared. So the equation of a circle can be in a form whereby you are able to identify the coordinates of a center of a circle. In this case, A and B represent the coordinates of the center of a circle. Okay, so this is one way we can give you the equation of a circle. Let me just point the specifically we can give you in this form. Let me write here. You can notice that x squared plus y squared equals to 4y minus 2x plus 44 can be written differently in this form. We can say it's x plus 1 squared plus y minus 2 squared equals to 49. So these are the two different ways of writing the equation of a circle. You can write it in this form whereby you are able to see the point of the center of a circle. In this case, when you look at x plus 1 squared plus y minus 2 squared equals to 49, we are able to see that the point of the center is -1 and 2. Okay, it's fine. We will continue. We will go deeper with this one. Do not worry. For now, the equation of a circle, it is given to you in this form. You are told that the equation of a larger circle, it's x squared plus y squared equals to 4y minus 2x plus 44. Okay, the smaller circle touches the straight line y plus x minus 5 equals to 0 at a point A. So what they are saying here, actually, they are saying that the small circle is touching the straight line only at one point, which is point A. So the small circle is touching the straight line at A, only at one point, which is at A. And also one can say the straight line is touching the small circle only at one point, which is point A. So we can see this straight line as tangent. We say this straight line, it is tangent. It is tangent to the small circle. So the line y plus x minus 5 equals to 0, it is the line of tangent. It is tangent to the smaller circle. Why am I saying this straight line y plus x minus 5 equals to 0 is tangent? It is tangent because it is touching the small circle only at one point. If you have got a straight line that touches the circle only at one point, we say that straight line, it is tangent. It is tangent to the circle. So actually, let us talk about tangent and secant. You have to understand these mathematical terms. What do we talk about when we talk about tangent, and what do we talk about when we talk about secant? So I'm going to draw here. Let me draw my circle here. Now, if there is a line that touches the circle twice, maybe let's say this line touches the circle at A and also touch the circle at B. So we are going to say this line is, we can call it a secant. A secant is a straight line touching the circle at 2 points. So it touches the circle at A and touches the circle at B. This line, this straight line, we say it's a secant. Now, if the straight line touch the circle only at one point, if the straight line touch the circle only at one point, let me draw the straight line touching the circle at one point. This is tangent. Suppose this tangent touch the circle only at one point. Maybe let me erase because I don't like the drawing there. I want it to be clear that the line touch the circle at one point. So let me say I have, yes, a line touching the circle at one point. This line will be called tangent. So we have got secant. You need to understand that secant touch the circle at 2 points. Tangent touch the circle at 1 point. So this straight line here, when we go back to our equation, when we go back to the question, y plus x minus 5 equals to 0. This straight line, I'm going to represent this line with a red color. This straight line touches the circle only at one point at A. So this straight line, it is tangent. This straight line is tangent. And what you guys have to recall now, this is very, very important for grade 12 purpose. I want us to look at the relationship between the tangent and the radius. So I'm going to do something like this. What I'm saying is going to be very important when we answer the problem. So we are laying the theoretical background so that you won't struggle when I start to make some calculations. So I'm going to draw a straight line from M to A. This straight line from M to A, it's my radius. It's a radius of a smaller circle. So the straight line from M to A is a radius. And now we have got this straight line that touch the circle only at one point, I said this line is tangent. So you have to understand the relationship between the tangent and the radius. You have to know that at the point of contact, whenever the radius and tangent meet, the angle at the point of contact is 90 degrees. So the angle here, I have a right to say it's 90 degrees because I know that tangent is perpendicular to the radius. This is the relationship between the tangent and the radius, and I want you guys to know this one. It's very, very important. As much as analytical geometry is concerned, you have to remember that tangent is perpendicular to the radius. This is a theorem also in Euclidean geometry. We say tangent is perpendicular to the radius, which implies that whenever tangent and the radius meet at their point of contact, the angle is 90 degrees. So that is why I'm saying the angle here is 90 degrees. The reason is that tangent is perpendicular to the radius. Another thing about tangent and a radius, you have to know that the product of their gradient is -1. If we take the gradient of tangent, if I say m of tangent, I'll just say m of tan is tangent times m of a radius. I'm referring to the gradient of a radius. So I'm saying if we take the gradient of tangent, multiply by the gradient of a radius, we must get -1. Why? Because tangent and the radius are perpendicular. The product of the gradient of perpendicular lines is -1. When we multiply the gradient of two lines that are perpendicular, we must get -1. So the gradient of a radius times the gradient of a tangent is -1. This is a very important relationship that you must be aware of. Concerning tangent and a radius, you must know that tangent and the radius, they are perpendicular. Okay. Now they are also talking about the straight line y equals to 0. They say the straight line y equals to 0 cuts the both circles. This one also is very important. We need to understand what they are talking about when they talk about the straight line y equals to 0. I'm going to show you a Cartesian plane. I'm going to have a Cartesian plane, which is made up of the x-axis and the y-axis. So now let me say I have got a 1 here. I have got the value 1 here. Now, if I draw a straight line, a straight horizontal line that pass through this y value of 1, like this, a straight horizontal line. This implies that the equation of this horizontal line is y equals to 1. You guys, you must be able to find the equation of a horizontal line. And when you are looking for the equation of a horizontal line, you don't make use of the formula such as y equals to mx plus c. And you also don't bother trying to calculate the gradient of a line. The equation of the horizontal line is the equation of y. So what we are saying is that actually the y value is always 1 along this line. So I'm going to represent it differently. Let me do this. Let me say we have got the y-axis and we have the x-axis again. Let me say I have got 1, 2. So let me talk about this point. Let me talk about a horizontal line passing through 2. A horizontal line passing through 2. This line, it has got an equation. The equation of this line is y equals to 2. What are we saying? We are simply saying along this line, the y coordinate will always be 2. So throughout the horizontal line, the y coordinate does not change. The coordinate that can change is x. So let me pick 2 points along my horizontal line. So let me pick the point here. I will say I don't know x at this point, but I know y is 2. Let me pick a different point along the same line. I still don't know the x value at this point, but the y value is 2. So throughout the horizontal line, the y coordinate does not change. So now you will understand what they are talking about when they talk about the straight line y equals to 0. And I will show you the Cartesian plane again, y-axis, x-axis. Here we have got the origin. We know that at the origin, y is 0 and x is 0. That is the origin. So the equation of this line y equals to 0 actually represents the x-axis. The line of y equals to 0, it is the x-axis. Which means the line of x equals to 0, it is the y-axis. Yes. So this y equals to 0 simply says along any point on the line, the y coordinate is always 0. And if we talk about the y coordinate being 0, we are talking about the x-intercept. That represents the x-intercept. If we talk about a point where y it is 0, we are simply talking about the x-intercept. Okay, I think now we are ready to go and answer the questions because we looked at the theoretical background of the question 1 of the assignment of 2025 grade 12. So the first question says, determine the coordinates of M. Let's go back. M is the center of the circle, is the center of both these two circles, is the center of a small circle and it's also a center of a big circle. M is the center of these two circles. So I want to find the coordinates of M, the center of a circle. I'm going to say, let us find the center of a circle of a larger circle. We are going to look for the coordinates of the center of a circle. Which circle? The larger circle. And we have the equation of this large circle. I'm going to write it down because they gave it to us here. What is the equation of a larger circle? It is x squared. Okay, something is happening. I'm trying to pick my pen, guys, here. Okay, the equation of a larger circle, it's x squared plus y squared equals to 4y minus 2x plus 44. This is the equation of a larger circle. I'm going to use this equation to find the coordinates of M, the center of this large circle, and also which is also the center of a small circle. But now I just want us to focus on it as it is the center of a large circle because we have the equation of a large circle. I'm going to use the equation of this large circle to find the coordinates of the center of this large circle. How so? We are going to take this equation, put it in a form whereby we can see the point of the center of a circle. I'm going to complete the square on this equation, x squared plus y squared equals to 4y minus 2x plus 44, which this one, guys, it can even come in your exam. This is very important ideas in analytical geometry. You should be able to take the equation of a circle which is given in a different form and convert it into a form whereby you can be able to see the point of a center of a circle. So let's go through it. I'm going to take minus 2x on the right side to the left-hand side. So I'm going to say x squared plus 2x plus, now let me take y squared here, y squared bring, I'm going to bring 4y to the left-hand side. So it's going to be minus 4y. Equals to 44. I'm not moving 44 from the right-hand side. I'm just leaving it that side. So the only thing that I brought to the left is 4y and 2x. Why am I doing this? It's going to be very important when I'm completing the square. This will help me when I'm completing the square. So I'm going to now focus on the coefficient of x. I'm going to focus on the coefficient of x. What is the coefficient of x? It is 2. What am I going to do to this 2? I'm going to multiply it by 1 over 2 and then square it. So I'm going to say 2 times 1 over 2 and then square. What is 2 times 1 over 2 squared? If you press your calculator, you'll notice it's 1. So now I'm going to have x squared plus 2x plus 1. The result, the number which I just got recently, I'm going to add with it. Now let me go to the coefficient of y. What is the coefficient of y? Negative 4. What am I going to do to the coefficient of y? I'm going to multiply it by half and then square it. I'm going to do the same thing which I did to the coefficient of x. So I'm going to say minus 4 multiplied by half and then square it. Minus 4 by half, it's negative 2. Negative 2 squared, it's 4. So I'm going to have, now I'm going to have y squared minus 4y. I'm going to add 4. And then say equals to 44. On this right-hand side, I'm going to add 4 and also add 1. What I did on the left, I will also do on the right. Remember, on the right-hand side, I added 1 and I also added 4. Let me circle those two numbers that I'm talking about. I added this one and I also added this 4 on the left side of the equal sign. So I'm also doing it on the right side of the equal sign. I'm adding 1 and I'm also adding 4. Now, what are we going to do? This x squared plus 2x plus 1, these three terms can be factorized. X squared plus 2x plus 1 forms a quadratic expression which can be factorized. And if you factorize x squared plus 2x plus 1, you will notice that we have got x plus 1, x plus 1. Okay? Plus, now let's go to y squared minus 4y plus 4. This one also is a quadratic expression. Y squared minus 4y plus 4 also is a quadratic expression which can also be factorized. How so? You can say y minus 2, y minus 2 equals to, on the right hand side now we're going to have 44 plus 4 plus 1, which is 49. 49. This is the same as x plus 1 being squared plus y minus 2 being squared equals to 49. So we can now know the center of these circles. We can now know the center of this large circle. Why am I saying this? Because we have taken it from the form and put it in the form whereby we can be able to see the point of the center of a circle. So what are the point of a center of a circle? It's -1 and 2. So it means that the coordinates of M is -1 and 2. So you found the coordinates of the center of a circle. One maybe is asking, how did I conclude that it's -1 and 2? If you take this x plus 1, which was squared, if you just say x plus 1, equate it to 0, and solve for x, you will get -1. So the one of the center of a circle is -1. Now, if you take from y minus 2 being squared, if you take y minus 2 and equate it to 0, you will see that the value of y is 2. So we have got the center of a circle as -1 and 2. So how many marks was this? It was 3 marks. Yes, I took a bit of a long try because I wanted to explain each and every detail. When you are learning, it's very important to explore all necessary details. We should not embrace shortcut. We should look at all necessary details. Very important to explore it in its totality. So we found the coordinates of the center of a circle. It is -1 and 2. So the coordinates of M is -1 and 2. M, -1 and 2. You get your 3 marks. Now, the second question says, determine the coordinates of A. Let us go and look at A. Let us go and look at the point A. I love this question actually. I love this problem where they say determine the coordinates of A. Let me erase here. Okay. Okay, I'm going to draw a line which is MA, the line from M to A, the line of the radius. This is a radius. And remember the coordinates of M, it's -1 and 2. So how do we find the coordinates of A? One thing that I want to erase, guys, one thing that I want to bring forth is that the straight line from M to A intersect with the line of tangent. So I'm going to show you the line of tangent with a blue color, which is the line of y plus x minus 5 equals to 0. This is the line of tangent. And this line of tangent is intersecting with a line of the radius. So this is a line of radius. So A is the intersection point of these two lines. So we can find the coordinates of A by viewing it as a point of intersection. How do we find the point of intersection? We equate the two equations. So I'm going to take the equation of MA and equate it to the equation of tangent, seeing A as the point of intersection. So we know that the equation of tangent is y plus x minus 5 equals to 0. This is the equation of tangent. So what is the equation of radius? What is the equation of a line from M to A? It is not given, which means we have to find the equation of this line from the center M to the point A. We have the point along the line MA. It's very important to know how to find the equation of a line. We have a point along that line MA. Remember, to find the equation of a line, you need a point along that line, and you also need the gradient of that line. So we need the gradient of a line MA. How are we going to find the gradient of a line MA? Don't worry, it's easy. Finding the equation of a line MA is going to be easy. Once you notice that the straight line MA, it is perpendicular to the straight line of tangent, because we said the radius is always perpendicular to the tangent. Tangent is this line of y plus x minus 5 equals to 0. So let me put this equation of y plus x minus 5 equals to 0 in the standard form. If I'm saying I'm putting it in the standard form, I'm simply saying, let me make y the subject of the formula. So I'm going to say y, where's my pen? I'm going to say y equals to minus x plus 5. Yes, I took positive x to the right-hand side and also negative 5 to the right-hand side. I am making y the subject of the formula. Why? If y is the subject of the formula, I will be able to identify the gradient of this line. Remember, the standard form of a line is this: y equals to mx plus c. So this implies that the gradient, my m, it's actually -1. So the gradient of this line, y plus x minus 5 equals to 0, the gradient of this line is -1. M is -1. So I have the gradient of this line of tangent. Remember, I said it's tangent because it's touching the small circle only at one point. So I have the gradient of this line of tangency. I'm going to use the gradient of the line of tangency to find the gradient of the radius, just because I know that these two lines, they are perpendicular. So I'm going to say m of tangent times m of radius is -1. How much is the m of tangent? M of tangent is -1. So I'm going to say -1 times m of radius is -1. So if you divide now both sides by -1, you divide this side by -1, you divide this side by -1, you see that the m of the radius, the gradient of a radius, it's 1. So now I have the gradient of a line from M to A. Remember, the line from M to A is a radius. So I have the gradient of this radius line, the straight line from M to A, to a straight line from M to A. I know that the gradient is 1. So because I have a point and I also have a gradient, I can find the equation of this straight line from M to A. How so? I'm going to say y equals to mx plus c. Let me start by saying y equals to, I know m, I know the gradient of this line of radius, it's 1. So it's going to be 1x, which is just x. Y equals to x plus c. So I have to calculate the value of c. I have to find c in order to complete the equation of a line from M to A. So I'm going to substitute y and also substitute x by any point along the line from M to A. And we see that point is -1 and 2 is the point of the center of a circle. So I'm going to say my y is 2, my x is -1 plus c. Therefore, c equals to 3. Now, what is the equation of this straight line? It's going to be y equals to x plus 3. Now I have the equation of these two lines. I have the equation of a line of a radius, and I have the equation of a line of tangent, which meet at a point A. So let me write these two lines close to each other together. I have the line y equals to x plus 3. This is a line of radius. And I have y equals to -x plus 5, which is a line of tangent. Now I'm going to solve these two equations simultaneously to find the point of intersection A, because the two lines meet at A. Don't forget, the two lines, they are meeting at this point A. Let me show you the line of radius. Yes, they are meeting at this point. So A is a point of intersection. So I'm going to take the equation of a line of tangent and the equation of a line of radius and solve them simultaneously, or one can say equate the two functions, because we are looking for the point of intersection. If you are looking for the point of intersection, you just equate those two functions that meet, those two functions that intersect. So I'm going to equate them. How so? I'm going to say, let me do this. I'm going to say minus x plus 5 minus x plus 5 equals to x plus 3. And then now I will solve for x. Let me pull x to the left-hand side. So it's going to be minus 2x equals to, let me pull 5 to the right-hand side, which is going to be 3 minus 5, which is negative 2. Minus 2x equals to negative 2. Then you divide both sides by negative 2. You divide by negative 2. Therefore, x is 1. It means that the two lines, the line of tangent and the line of radius, they meet at A, where the x coordinate at A is 1. So now I have to find the y coordinate. And when you are looking for the y coordinate, just go to any of those two equations. Pick any of those two equations, substitute x with 1. So I'm going to take the line of a radius, which is y equals to x plus 3. Y equals to, substitute x with 1, 1 plus 3, y equals to 4. So the coordinate of A, therefore, is 1 and 4. The coordinate of A, it's 1 and 4. It was the point of intersection of a radius and the tangent. That was a key concept. Okay. Before I go to 1.3, let me do this. Before I go to 1.3, let me say, suppose, guys, you have got two graphs that meet. Let's say you have got a quadratic graph, parabola graph, which meet with a straight line. Let's say they meet at A and they meet at B. How can you find the coordinates of A and B? These coordinates of A and B is the point of intersection. So you need to know how to find the point of intersection. How do we find the point of intersection? We just equate the two functions. If my parabola is f of x and my straight line is g of x, to determine the coordinates of A and B, which is the point of intersection, you simply take f of x, you equate it to g of x. You are looking for the point of intersection where the two functions meet. The point of intersection is very important for grade 12. You need to know how to find the point of intersection. You equate the two functions. Okay, now I think I will go to 1.3. It's very important to keep my information, kind of what the m is negative 1 and 2. A, I said it's 1 and 4. I might need this when I'm solving other questions. So let's check now. They are saying determine the equation of the smaller circle. Okay. I love this assignment. It's very good, especially for analytical geometry, this question is very good. You should be able to find the equation of a circle. And these are the easy questions that we normally pass our maths grade 12 with. Please, 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 grade 12, you must be able to determine the equation of a circle. And I need two things. For me to find the equation of a circle, I need to know the center of a circle. I need to know the coordinates of a center of a circle and also have at least one point at the circumference. So this guy here, the examiner here, is looking for the equation of a small circle. I will just highlight this circle with a red color. And I said, I need two things which are very, very, very important. What do I need? I need the central point. For me to find the equation of this circle, I need the central point. Do I have the central point? Yes. The point of the center of this small circle is -1 and 2. So I do have the point of the center of a small circle. And I also need one point at the circumference of a circle. Do I have one point at the circumference of a circle? Yes, it's point A. We see that the point A lies on the small circle. It lies actually on the straight line of tangent, and it also lies on the small circle. So I do have a point on the circumference. It's 1 and 4. Point of circumference, which is 1 and 4. So with these two, I can be able to find the equation of a small circle. The first thing that you write down is the formula which will help you to find the equation of a small circle. And which formula is that? You write this formula. You say x minus a squared plus y minus b squared equals to r squared. Now a and b, we are going to substitute a and b by the point of the center of a circle. A and b represent the central point. So let me start with that. Let me substitute the point at the center of a circle first. So I'm going to say x minus, take the point from the center of a circle, which is -1 squared plus y minus b is 2. The point of the center of a circle is 2. The y coordinates at the center. Then I say equals to r squared. Okay, now I'm going to substitute this x and this y by any point from the circumference. So my x, if I go to the point from the circumference, which is 1 and 4, the point at the circumference of a circle, it's 1 and 4. So my x is going to be 1. I'm going to say substitute x with 1. I'm going to say 1. This negative times negatives is positive. So it's 1 plus 1 squared plus, I'm going to substitute the y with 4. So it's going to be 4 minus 2 squared equals to r squared. So I have 1 plus 1 is 2. I have 2 squared, which is 4. 4 minus 2 is 2, which is 2 squared, it's 4, equals to r squared. So 8 equals to r squared. Now I can give you the equation of a circle. I will come back to this formula, x minus a squared plus y minus b squared equals to r squared. Now I will say x minus, what is a? It's a -1. Remember, a is the point from the center, -1. So it's going to be minus 1, which is going to be x plus 1 squared plus y minus b is the y coordinate of the center of a circle, 2 squared equals to r squared. R squared, it's 8. So I found the equation of a small second, which is x plus 1 squared plus y minus 2 squared equals to 8. 2 marks. Wow. I wish they had given bit more marks for this one. 2 marks. Okay, let me erase. But I need to write this equation down just in case I might need it when solving other problem. So it's x plus 1 squared. Bear with me when I'm writing it down. Plus y minus 2 squared equals to 8. Okay, now I'm going to look at 1.4. Okay, which is the last problem on question 1. Okay, the straight line y plus, let me pull this one down. Okay, yeah, I think this is what I might need. The straight line y plus x minus 5 equals to 0. Remember, this is the line of tangency. This is the line of y plus x minus 5 equals to 0. Yes, the straight line y plus x minus 5 equals to 0 meets the straight line y equals to 0 at a point k. Okay, the straight line y equals to 0 is this one. I'm showing it with a red color. So they say it meets at k at this point. And this point to me is the x-intercept. Actually, is the x-intercept of the line y plus x minus 5 equals to 0. Because the line y equals to 0, guys, do not forget, is the x-axis. They did not show us the y-axis, but this is the x-axis. And we know that whenever the function cuts the x-axis, that point, we call it the x-intercept of a function. So the straight line y plus x minus 5 equals to 0 cuts the x-axis at k. At this point k. So that k is the x-intercept of this line y plus x minus 5 equals to 0, which means I can be able to find the coordinates of k. I can find the coordinates of k by letting y to be 0, because I'm saying that is the x-intercept. At k, y is 0. So I can say 0 plus x minus 5 equals to 0. Therefore, x equals to 5. If we take negative 5 to the right-hand side. So the coordinates of k, it's 5 and 0. I'm going to write these coordinates as they might be very, very, very useful. It's 5 and 0. Okay, so they say the straight line y plus x minus 5 equal to 0 meets the straight line y equals to 0 at a point k. So there's at k, y is 0. You simply have to find x, and we found that x is 5. Find the area of a triangle AMK. So let us look at the triangle they are talking about. They are looking for the area of a triangle AMK. They are looking for the area of this triangle. Maybe let me highlight with a different color so that it can stand out. Yes, the area of this triangle. Triangle AMK. Yes, do not forget that at A, at this point, the angle here is 90 degrees. So the triangle AMK is right angle triangle. So we are looking for the area of a right angle triangle. How do we find the area of a right angle triangle? We just say half times base times perpendicular height. This is how we find the area of a right angle triangle. Half times base times perpendicular height. So I'm going to see MA as my height, these two sides which are perpendicular to each other, and see this one as a base. Okay, so my height is a distance from M to A, and I know that the distance from M to A is referring to the radius. And I think I know I can find easily the length of M to A. I can find the radius so easy. Let's go back and look at the equation of a small circle. The equation of a small circle is x. I said we might need it, and yes, I wrote it down. X plus 1 squared plus y minus 2 squared equals to 8. Okay, which means that if you look at the value on the right hand side, this positive 8, this is on the right side. This is on the left side of the equal sign. If you look at the value on the right side, it is equivalent to r squared. This is why we put r squared. Remember the formula, guys, is like this. X minus a squared plus y minus b squared equals to r squared. So this 8, it's equivalent to r squared. So now I can say, okay, r squared equals to 8. Put the square root both sides. So I'm going to say r equals to plus or minus square root of 8. Every time when you involve the radical, when you involve the root, you need to say plus or minus. But because I'm referring to the radius, which is a distance, the distance can never be negative. So I will say my r is square root of 8. My r is square root of 8. The radius, which is the distance from M to A, the radius of a small circle. So I already have this side of a height is the square root of 8. MA, I took it as my height of this small circle, of this triangle AMK. Remember, I want to find the area of a triangle AMK. So I found my height, my perpendicular height. I'm saying it's square root of 8, which is the distance from M to A. You can even use the distance formula, but just because I know that is the radius, it was easy for me to say r squared equals to 8. Now I need to find the base side. I need to find this side, which I'm referring to it as a base. So, which is the distance from A to K. What are the coordinates of A? I need to recall the coordinates of A. Didn't I write the coordinates of A somewhere? I will have made a big mistake if I did not write the coordinates of A. Yes, I wrote the coordinates of A. It's 1 and 4. We did find this coordinate. It's 1 and 4. So I can find the distance from A to K, which is my base. I will use the distance formula. I will say AK is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. Therefore, AK equals to the square root of my x2. I'm going to say CK, the x coordinated k as my x2, which is 5. So I'm going to say 5 minus 1 squared plus my y2 is going to be 0, 0. My y1 is going to be 4. 0 minus 4 squared. So my AK is equals to the square root of, I see 16, press your calculator guys, plus 16, which is the square root of 32. So AK is the square root of 32. Now I can find the area of a triangle AMK. It's a half. What is my base? My base, I said, is the distance from A to K, which I found the square root of 32. What is my perpendicular height? I said it's the distance from M to A, which is the radius of a small circle. And I noticed that is the square root of 8. So the area of triangle AMK, it's a half times square root of 32 times square root of 8. Please press it on your calculator. You will find the area of a triangle AMK. I love this assignment. I really love this assignment. I wish that you do it by yourself. You can use this video for practice, but I wish you do it for yourself. You know how to do it. And I know that you're going to write this one in a classroom. So you practice it, and then in the classroom, when they bring it, please do it by yourself and do it with understanding. Make sure that you understand every concept that we talked about here, such as tangent is perpendicular to the radius. That is a very important concept there. You need to recall that when you take the gradient of tangent times the gradient of a radius, it has to give you -1. You need to know how to find the equation of a small circle. What do you need to find the equation of a small circle? You need the point at the center, and you need 1 point from the circumference. So, and another very, very, very important and amazing question was to find the coordinates of the center of a circle M by completing the square. Guys, this is a very good question. Things like this do come in your exam. So please make sure that you understand what we are doing here. And please, please, please subscribe to my YouTube channel. I just made equation 1. I'm going to create a playlist. So I'm going to stop this video, and then I'm going to create problem question number 2. So there will be a playlist. After question 1 end, make sure that you see question number 2. See you next time. Keep visiting Academic World by Mpakele TL. Thank you so much. I'm going to end the meeting here.